All right. So welcome back. In part one, we already saw that we know what number bases are. They're the counting system. Basically, a number system, a number base um, has a certain number of digits that you use in the system. Okay. So based on the number of digits that you use, you will write the numbers differently. Okay. Like for example, we know that in base 10. By the way, the base 10 is also called a decimal system. So that's the most common one that we use. In base 10, 12 is written as 12, right, in base 10. But in base 2, you can work it out. But 12 in base 10, right? In base 2, it's written as it should be 1. All right, this should be 12 in base 2, meaning the binary system, right? So you see the difference how we write. Okay, like in base 2 we can only use 1 and 0, whereas in base 10 we can use any number from 0, any digit from 0 to 9, right? So we write the same number in different ways in different number bases. All right, so then first we learned how to convert from other bases to base 10. So if you see in part 1 of this series, you will notice that the way to convert it is to, for example, we did. So let's go back to our example. Like if you look at 312 in base 5, and I'm asking you to convert it to base 10, which is the normal decimal system that we use. So what you do is essentially you take the first digit on the right and multiply it with the base to the power of 0. So now the base is 5, so you multiply it by 5 to the power of 0. Okay, then you take the second digit, which is 1, and you multiply it by 5 to the power of 1. Take the third digit, multiply it by 5 to the power of 2, and then you add up all the things that you multiply. Then you will get the answer in base 10, right? So we did this, and then if you change the base, for example, if this 5 changes to 8, then this thing, all the multiples will also change. So in the first digit you'll multiply with 8 to the power of 0, not 5 to the power of 0, and then the second digit with 8 to the power of 1, third digit with 8 to the power of 2. Okay, and then you add them up again, then you'll get a different answer. So this is the system, and this is the conversion from other bases to base 10. Now what we're going to look at is part B, which is from base 10 to another base. So a reverse process. Okay, and then part C, which is from one base that is not 10 to another base that is also not 10. So basically like from base 5 to base 8, something like that. Okay, both bases are not 10, so how do you do that? Okay, so it's not really complicated. Now first we will look at in base 10 to another base. Okay, the method is called repeated division. Okay, and I think the meaning is pretty direct. It's very straightforward, right? Repeated division meaning you divide the number repeatedly. Okay, so let's take example. Now say I have the number 77. Okay, this is in base 10. I want to now convert this number to base 8. Alright, okay, so how do I do this? So to start my repeated division, I first take the number, so the number in base 10, which is 77, right? I take 77 and I divide it with the base 8. So notice that this is the number in base 10 and this is the base. Okay, and then you divide it. What do you get? You will get, so what's 77 divided by 8? The closest number you get is 9. And then you will have a remainder. So the remainder is very important. You write the remainder at the side. So what is the remainder? 9 times 8 is 72, so you have a remainder of 5. Okay, cool. Now since it is repeated division, basically you repeat the step again. So you take 9 and you divide by 8 again. Okay, take 9 divided by the base, you'll get 1 with a remainder of 1, right? 9 divided by 8 is 1 with a remainder of 1. Again you take this 1 and you divide the 8, you'll get a 0 with a remainder of 1. Alright, so your answer, if you're wondering where your answer is, your answer is this thing here, but you must read it in this upward order. Okay, meaning the answer 77 in base 10 is equal to 115 in base 8, not 511. Okay, you must read it in upward order. So this upward order is very important. All right, so you read the lowest number first. So basically repeated division means you divide and then you get a number, then you put the remainder on one side, you divide it again, then you get another number, you put the remainder on the other side, you divide until you get 0. You stop at 0, because after 0, no matter how much you divide, you don't get a remainder anymore. Okay, so there's no use. You stop at 0 and then you collect the remainder at the side. So this is the remainders. Right, these are the remainders. You read it from bottom to top, so you get 115 in base 8. All right, so that's how you do it in that's how you convert a number in base 10 to another base. Okay, so if you try 77 base 10 to base 5, it's the same process. All right, you take 77, you divide it by 5, you will get 75 with the so 75 is the nearest multiple, and that is 5 times 15. All right, and you'll get a remainder of 2. Then 15 divided by 5, you'll get 3, remainder 0, and then 3 divided by 5, you get 0 with a remainder of 3. Then you read it this way. Okay, you take this remainder and read it upwards. So the answer is, so you have 77 base 10, this will be equal to 302 in base 5. Alright, okay, so now we are done with converting base 10 to base to other bases. So we are already done with this part as well. Okay, we have already done with part A, we're done with part B. So we only have C left. Okay, which is converting from one base that is not 10 to another base that is also not 10. Okay, so converting between bases not 10. Okay, all right. How do you do this? Well, if I want to change a number in base 5 to base 8, okay, technically there's no direct method. Okay, I mean, you can try to find some special cases you have direct methods, but then, like for this case, there's none. What you can do is, instead of doing this direct conversion, why don't you convert to base 10 first? So if you look at what we have covered, base 5 to base 10, okay? So which method is this? This is what we did in part A, which is the other bases to base 10, right? Base 5 to base 10. So this is method A. And base 10 to base 8 is what we discussed just before this, which is part B. So then you can do it. Alright. So let's take this number 302, okay, and prove that our answer is right. Okay. Just to note, in base 8 our answer was 115. So from 302 we need to get 115 in base 8. So now the question is 302 in base 5, we want to convert to base 8. And before converting to base 8, we go to base 10 first. So we go to base 10, then base 8. Okay. Okay. So let's do 3025 to base 10 first. How do you do base 10? So you remember, if you want to convert to base 10, we did this in part 1. You take the first digit 2. So you take 2 times, what is the base? The base is 5, right? So 5 to the power of 0 plus 0 times 5 to the power of 1 plus 3 times 5 to the power of 2, right? So this is 2 plus 75. This should be 77 in base 10. Okay. So do you see what we have now? Do you remember the number 77? Okay. So this is how you can check your answer. Remember just now we did this. Look at this. So we wanted to convert 77 to base 5. Okay. We did this repeated division and we got 302 in base 5. Now we take 302 in base 5 and we wanted to convert back to base 10. And guess what we got? The same answer that we began with. We got back 77. So basically you can check your answer like this. Okay, you convert to base 10. If you convert something from base 10 to base 5, for example, then if you do the reverse process, you should get the same number. If you don't get the same, then something is wrong. So here we did it the right way. Okay, so now here base 10 we have what? We can erase this base 10, we can replace with 77 in base 10. So now the second step, 77 from base 10 to base 8. I can repeat this step, but actually this step we have already done here. This is what we did. We did 77 in base 10 to base 8. Okay, we did this method and we got 115 in base 8. Alright, actually I don't have to repeat this method, it's already here. So just look at it. We did repeated division. We took 77, divide by the base, and then collect the remainder and divide the quotient by the base again, then get the you get 1, and then you get the remainder. You do the same until you come to 0. Alright, you just repeat the division until you come to 0, and then you collect all your remainders in the upward. So this is very 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 important. Okay, the order is very important, because if you write 511, this is wrong. Okay, it is 115. Cool. So the upward order is very important. So then we know that 7710 is equal to 115 in base 8. We have already done the working. Okay, 115 in base 8. So we got our answers back. 302 in base 5 is the same as 115 in base 8. Alright. Okay, so so the key thing is, okay, first you convert to base 10. Meaning, how you convert to base 10? You use this multiplication and addition that we did in part 1, the previous video. Alright, and then from base 10 to base 8 we do repeated division. Okay, alright, now I'll give you a special trick which only applies, so only for base 8 to base 2 conversion. Alright, this is special. Now say I have a number in base 8. The number is 115. Let me just write this. Okay, okay, so this is sorry, let me just write 105. Okay, okay, base 8. I want to change to base 2 or binary lah. Okay, now instead I can definitely do 105 base 8, find the base 10, and then find base 2. I can do this, not a problem. This is correct, but this is long. Okay, and for the special case, remember, yeah, this is only for base 8 to base 2. Okay, I can do a special method, and this method is, so I have the number 105. This is in base 8, so this is in base 8. Okay, now what I need to do is I divide these digits, right? I like separate these digits. Now I convert each of the digit, okay, each digit to the binary system. So what is 5 in the binary system? Okay, let's refer here. I mean, well, you can always do the working, but okay, so what is 5 in the binary system? 5 is 101, right? So basically the method is you run individual base 10 to base 2 conversion. Okay, basically, 5 in base 10, how you convert to base 2? You can do that multiplication thing, right? Oh, sorry, you can do repeated division, right? So if 5 you divide by 2, you get, yeah, you get 2 with a remainder of 1, and then you divide by 2 again, you get 1 with a remainder of 0. You divide it by 2, you get 0 with a remainder of 1. So 101 is your, go this way, 101 is your answer. Okay, or you can refer from here. Remember, uh, 4 in base 10, so 4 in base 10 is 100 in, I mean not 100, sorry, 100 in base 2. So 5 is just one more than that, it's 101. Okay, this thing. So then 5 is 101. So you write a 101. Okay, similarly 0 is just 0, so this is 0 0 0. You must write 3 digits. Okay, so these are all 3 digits, 3 digits. Okay, and how about 1? 1 is just 1, so this will be 0 0 1. Okay, but if it's 0 0 1 on the left, you can take out the 0 lah. Okay, but on the right you cannot take out 0. Okay, like if you have like 104, what you'll get is 0 0 1 0 0 0 1 0 0. These zeros you cannot take out. The 0 on the right you cannot take out. Okay, 0 on the left you can always take out. All right, so then what we have is our final answer, 105 in base 8 is equal to 1000101 in base 2. Okay, this 3-digit method, okay, one of the reason, so uh, I'm not going to explain too much, but then I'm just going to tell you that the reason, okay, to this, why this logic works, is that you realize that 2 to the power of 3 is 8, right? So that's why when we, and then if you realize, uh, 8 in the decimal system is the first number where, how do you write 8 in binary? You write 1000. So this is the first number with 4 digits. So all the numbers that are under 8, okay, will have a maximum of 3 digits. Okay, like 7 in the 7 in the decimal system is 111 in the binary. Okay, and 7 is the highest 3-digit value in the binary. 111 is the highest, because after 111 you get 1000, right, which is 4 digits. So this is the reason this thing works, but you don't really have to know why it works, as long as you know that this method can be used. All right, so that's it. I hope you have fun. Sorry, I thought it would be shorter than the last video, but we didn't make much difference. It's okay. I hope you just learned enough, and yeah, I'll see you in the next video on maybe another chapter. All right, see you, bye.